Hi, I'm Clara, and we're doing Unit 5.1.2, or How Can I Determine the Inverse and Inverse. So, some of the vocabulary you need to know for this unit is, so an inverse is the reverse order of operations of an equation. A function is an equation that has one output for every input, and then the line of symmetry is a line that divides a picture or a line that divides something into two congruent parts.
I'm Sierra, and for some of the continued vocabulary, you also need to know domain, which are all of the possible x values for a given graph, and range, which is all of the possible y values for a given graph, as well as input, which is the value that you substitute in for x in an equation, and output, which is the number you get from an equation when you have an input.
Okay, so the first example problem that we're going to do is number 25 from the homework section of 5.1.2. And so this problem was graph the function f of x equals 1/2 parentheses x minus 1 parentheses cubed, and its inverse. So first we're just going to graph this. Okay, so because of the function, of this equation of the function, we know that it's going to be shifted over to the right 1 and pass through the point 0, 1. And it's stretched to the 1/2. And so when you put 0 in for x, you're going to get negative 1/2. So it's going to go through the point 0, negative 1/2. So it's going to look something like this. So that is your parent function. Now, to graph the inverse, so to graph the inverse of a function, you just can reflect it over the line y equals x, which is this line right here. This dotted red line is y equals x. And so, if we reflect the parent function over y equals x, it's going to cross right there and at 1/2. So it's just going to look like that. So the blue is your inverse function and the yellow is your parent function. And that's one easy way to graph the inverse of a function.
So problem 26 is dealing with inverse equations. So for this one, you're supposed to find the inverse of 3x minus 8 equals y, 1/2 x plus 6 equals y, and x plus 6 over 2 equals y. So for A, 3x minus 8 equals y. So a really good way to solve these is by substituting x and y. So instead of 3x minus 8 equals y, it would be 3y minus 8 equals x, and then solving for y. So for this one, you would first add 8 to each side. Then you have 3y equals x plus 8. And then you would divide by 3 on each side. So y equals x plus 8 over 3. And so x plus 8 over 3 is the opposite of 3x minus 8 equals y. And then for b, we're going to do the same thing and substitute x and y. So it would be 1/2 of y plus 6 equals x. So you're going to subtract the 6. And you have 1/2 y equals x minus 6. And then you're going to divide by 1/2 on each side. So in reality, you're multiplying by 2. So you'll have 2x minus 12. 2x minus 12 is the opposite of 1/2 x plus 6. And then for the last one, the inverse, you're again going to substitute x and y. So you have y plus 6 divided by 2 equals x. So the first thing you're going to do is multiply by 2 on each side. So you have y plus 6 equals 2x. And then you're going to divide or subtract 6 from each side. So y equals 2x minus 6 is the opposite of x plus 6 divided by 2.
Okay, so the next problem we're going to do is problem 29 in 5.1.2. And so this is a little bit of a story problem. So it says, Lacey and Richens each have a personal function machine. Lacey's machine, L of x, squares the input and then subtracts 1. Richens' function machine, R of x, adds 2 to the input and then multiplies the result by 3. So part A of this problem is write equations that represent Lx and Rx. So first we're going to write equations for each of the functions. So L of x, it said that it squares the input, so x squared, and then subtracts 1. So that is the function for L of x, or Lacey's function machine. And then R of x, it said that it adds 2 to the input, so x plus 2, and then multiplies the entire thing by 3, so. And those are our two functions for the function machine. So part B of 5.29 is Lacey and Richens decide to connect their two machines so that Lacey's output becomes Richens' input. If 3 is the initial input, what is the final output? So what this problem is asking you to do is to plug in 3 because it's your input. So 3, you plug in 3 for x into Lacey's function first, and then whatever output you get from Lacey's function, you plug that in as the input for Richens. So now I'm going to do that. So if your input is 3, 3 squared minus 1 equals 8, because 3 squared is 9, so 9 minus 1 equals 8. And then you plug 8 into Richens' function. So 3 times 8 plus 2. 8 plus 2 is 10, and 3 times 10 equals 30. So 30 is the final output that we get when we stack Lacey's and Richens' function machines and use 3 as the initial input. So after part B, which would be this stuff in the yellow, the problem asks us to, what if the order of the machines is changed? Would it change the output? Justify your answer. So it's asking us to switch which function we do first. So we do Richie's function with 3 as the input, and then use that output in Lacey's function. So I'm just going to do that to see if they are equal. So R of x equals 3 times 3 plus 2, if we're using 3 as our input. So 3 plus 2 is 5, and 3 times 5 is 15. And then we're going to take that 15 and we're going to put it into Lacey's function. So 15 squared minus 1. 15 squared is 225. So 225 minus 1 equals 224, which does not equal 30. So when you reverse the order of the function machines, you do not get the same output. So that would be the justification for this, is that 224 is not equal to 30.
So for question 530, it says a circle has the equation x squared plus y plus 2 squared equals r squared. If the circle is shifted 2 units to the left, 5 units up, and the radius is doubled, what will its new equation be? So first, we have to look at the equation for a circle, which is x minus h squared plus y minus b squared equals r squared, where h is how far you're shifted to the right or to the left. B is how high or low you're shifted, and r is the radius of your circle. So in order to shift it 2 units to the left, h has to be -2. So because it's 2 units to the left, we know we have -2, and it's x minus h, so it's minus -2. And then our y is already shifted down to -2 because we know it's minus b. Minus negative is +2. So in order to shift it 5 units up, we have to subtract 5. So instead of y minus 2, or y plus 2, we have y minus 3, because that's 2 plus -5. And then the last thing that we're doing is doubling our radius. So that's really easy. You just have 2r, but because of your order of operations, it has to be 2r squared, because your radius squared is how you make your circle. So then you put in your signs, and your final equation is x plus 2 squared plus y minus 3 squared equals 2r squared.